Chapter 4, Section 1 continuing on with our exponential functions and talking about the natural base e. E is a number. You can find it on your calculator. It's an irrational number, just like pi. So if I'm looking at the TI 84, you have your pi button here above the caret. And then right here is E, right above the division sign. We also have a button here on the calculator, ln, which is your natural log. And then the toggle button would be e to the power of x. Because your natural log is a logarithm with base e, and so it makes sense that they would be inverses of one another. Okay, so if I turn on the calculator, I'm going to clear out my home screen, go second division to get that number e, and I see e is equal to 2.718281,828. Decimals keep on going. They don't stop, they don't repeat, just like pi. So e is a number, and it is irrational. The irrational number e appears as the base in many applied exponential functions. This irrational number is approximately equal to 2.72, just like we approximate pi as 3.14. More accurately, E is approximately 2.71828. The ellipses indicating that it keeps going, doesn't repeat, doesn't stop. The number e is called the natural base. The function f of x equals e to the x is called a natural exponential function. All right, so example 5. Application problem, the function f of x equals 6 times e raised to the 0.013x. I like to highlight or circle my function so I get all of the characters. This function describes the world population, f of x, in billions, so measured in billions, x years after 2000, subject to a growth rate of 1.3% annually. Now if we look, this 1.3 is up here in the exponent. Okay, so anytime you have percents, you have to convert them to decimal, which means you move it decimal place 2 places to the left. So that's 0.013. And so that is that right there. Annually means every year. Use the function to find the world population in the year 2050. So we have to use our given function, f of x equals 6 times e to the 0.013x. We can find our x because we know x is years after 2000. So if we're looking for 2050, then our x value is 50. So we substitute 6 times, and it's like times this thing raised to this power. So on the calculator, it's best if you take e to that power, excuse me, and then multiply by 6 afterwards. You can use e to the x, okay, it gives you the caret right away. 0.013 0.013 times 50. Remember, that has to be in parentheses. I'm going to hit enter. And then I'm going to multiply by 6. And I get 11.49 if I'm rounding to the nearest hundredth. So f of x is approximately 11.49. And remember, when you're rounding, you need to use the approximately equal to symbol. And since this is an application problem, we're going to answer with a sentence: the world population in 2050 will be, or is expected to be, about 11.49 billion, because remember it said it's measured in billions, and my units are people. Now this model probably came from some data, and some statistician came up with a function that models the current conditions. Okay, so according to this model, the world population in 2050 will be about 11.49 billion people. Compound interest. Okay, we're going to have two different types of interest in this section. And if you know how to use the formulas and you know how to identify which formula to use, these are not difficult. Compound interest is interest computed on your original investment, as well as on any accumulated interest. Sometimes you have investments that send you interest payments, but sometimes you could have an investment where you keep the interest in with your investment, and then the following month they give you interest on top of that interest. So we say compound interest. Interest is compounded semi-annually if it's paid twice a year or every 6 months. Okay, so this goes based by the year to figure out how many compounding periods there are. So if you are told the interest is compounded every 6 months, you would know that would mean twice a year or semi-annually. Interest is compounded quarterly if it is paid every 3 months. So again, in terms of a year, take 12 months in a year, divide by 3, you get 4. So there are 4 payments in that year. So compounded quarterly if interest is paid every 3 months or 4 times a year. And we have to be able to take the vocabulary and convert it into a number, like quarterly. We'd have to know that the number of times interest is paid is 4 when it's quarterly. If it's monthly, then the number of times interest is paid in that year is 12, and so on. When interest is paid n times a year, we say that there are n compounding periods a year. And we use the formula A, the amount in the account, is equal to P, the principal amount invested, times the quantity, 1 plus R over N, R being the interest rate, N being the compounding periods, raised to the NT power, and again, is the number of times interest is paid in the year, And t is our time in years. So we're going to identify all these variables down here at the bottom of the page. So again, A is the amount of the investment, or the balance. P is the principal amount that you invested. R is the interest rate. And folks, the interest rate has to be in decimal form. So if the interest rate is 6%, you have to convert it to 0.06. All right, what didn't we cover yet? We got the A, we got the P, we got the R, we need the N. N is the number of times interest is paid in 1 year. So again, if it's annually, that's every 6 months, that's twice a year. So N would be 2. And then finally, we have to identify T. T is time, but it's time in years. So if it's 1 year, then T is 1. All right, we're going to do some problems using these interest formulas on side 2 of the notes. But before we do that, we're going to talk about continuous compounding. All right. Some banks use continuous compounding. Which is okay if you are getting the payments as an investment, but if you're borrowing money and they use continuous compounding, it's dangerous. So some banks use continuous compounding where the number of compounding periods increases infinitely, compounding interest every trillionth of a second if they want to. As N, which we know is the number of compounding periods in a year, increases without bound, the expression, this expression 1 plus 1 over n raised to the n power, approaches this number that we just talked about in the beginning of the lesson called E. And if we look at the table here, here's n, and here is our formula. So when n is 1, the formula evaluates at 2, right? Because you would put a 1 in here and a 1 in there. This would be 1 plus 1 over 1, which is 2. Raised to the power of 1 is 2. When n is 2, this changes a little bit. And as this gets larger and larger and larger, we see that this number approaches E. Okay, so back on my calculator, 2.718, 281,827, 2.718,821,828. So the next digit here must be a number larger than 5 to round that on this calculator up to the 8. Okay, so that's where E comes from. Just like we know pi comes from the diameter and the circumference of a circle. Okay, so it's not a made-up number, it's real, it exists. And as a result, the formula for continuous compounding is A equals P, the principal, times E raised to the RT power. How do I remember the formula to use? Well, if the compounding is continuous, it's the formula with E. And I make the connection that since these decimal places don't stop and they continue, this is the formula that goes with the continuous compounding. All right, so let's look at our application problem using these formulas. And let's see what it's asking us to do. A sum of $10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years, subject to quarterly compounding and then continuous compounding. So part 1 is quarterly compounding. All right, let's identify what we have here. $10,000 is not A. That's my P. That's the principal amount that's being invested. Remember, it's asking us to find the balance, which means we're solving for A. 8%. Remember, our percents have to be converted. This is 0.08. Remember, you divide by 100. Find the balance in the account after 5 years. Well, 5 is my T value. Quarterly compounding. Quarterly, that's 4 times a year. So N is 4. Here, T is 5. And P is 10,000. Continuous compounding, this is where we're going to be using E. So part A is using the first formula, which is A equals P times the quantity, 1 plus R over N, raised to the NT power. Now, on an assessment, you would be given the formulas. So you don't have to memorize the formulas. You just have to know how to use them. All right, I'm solving for A. I'm going to substitute the value of P, 10,000, 1 plus R, 0.08, divided by N, which is 4, raised to the NT power. Well, N is 4, T is 5. So this becomes raised to the 4 times 5 power. So why don't you pause the video and type this into your calculator and see what you come up with. Okay, it's going to be beneficial if you do this and pause the video and try this on your own so that you see if you can get this right the first time. If not, then you would know that you're making a mistake and you would have to, fix that mistake so that you're not getting this wrong in the homework and or on your assessments. So remember what I said, if you break it down into smaller chunks, you should be able to get the correct answer. Okay, hopefully you type this in on your calculator on your own. And you should have gotten $14,859.47. So, if you did not, let's see how I would type this into the calculator. Well, first of all, I would do what's inside the grouping. I would do 0.08 divided by 4, and I would hit equals. After I hit equals, I would do add 1, because that's what's inside the grouping. Now I'm going to raise that grouping to the 20th power, because 4 times 5 is 20. And then, once I get that result, I'm going to multiply by 10,000. $14,859.47. Folks, you have to round to 2 places here because it's money. Okay, so again, if you want to put this in the calculator in one fell swoop, you got to use a lot of parentheses. So personally, I think it's easier and quicker if you just do the little guy in the parentheses, add 1, then raise that result to this power, and then take that result and multiply it by 10,000. The second part is continuous compounding. And that's our other formula that we just learned about. A equals P times E raised to the RT power. Or sometimes students call it PERT because it looks like it spells PERT. All right, so we're still solving for A. P is still 10,000, nothing has changed. E is just E. R is my rate, 0.08, times T is 5. Now this you can put in the calculator. You can hit E to the X, and then find that result multiplied by 10,000. So go ahead and try that as I'm trying it. And here is my result. I did E to the that multiplied with that as my exponent. Got this result. And I took the result and multiplied it by 10,000. You should have gotten $14,918.25. $14,918.25. So if you have questions on any of these formulas, please let me know. If there's something that you think you might be doing incorrectly on your calculator, let me know so I can help you with that. And one more thing I always like to mention to students, and since I don't always have students in the classroom, you know, when and if you become a college student, credit card companies and banks, they like to send you offers in the mail for credit cards. But look at this percentage rate. You want to try to stay away from that. See, they will bombard you with credit card offers because they know you want things and they know you're hungry and that you use the credit card to buy food. Okay, so just be cognizant of a 24.99% rate. You do not want to have a percentage rate like that. And depending on your credit standing, you may or may not get that rate. You might end up with a higher rate if your credit is not good. Now, it is good to get at least one credit card to start building credit, but you can't abuse it. Okay, and these forms right here are the most important things when you get an offer for a credit card to look at. You know, here it's saying annual percentage rate, well, 0% introductory for 12 months. So I can buy things and charge things and not charge any interest. But after 12 months, I have to pay that balance off or I'm subject to this high rate. Okay, and then they do continuous compounding on the interest. So once that interest becomes part of your balance, you're going to get charged interest on that interest. And so on the next month, you'll get interest charged on the interest that was charged on your interest. Okay, so they will compound it. The other thing is, one time I got this nifty offer for this heavyweight champ, cool looking credit card. The only thing is, when I read, you know, here they make this all look good. 2% cash back, okay, cash back redemption. So here for airfare, here for just cash back. Annual airline credit, $100. They make this look good. VIP, luxury card, travel. But remember, this, with your interest rates and your disclosures, is the important paper to look at. 16.49, well, that's better than 24.99. But be careful because some of these cards have an annual fee. And this annual fee is $495. Plus, if you have other people that are authorized users on the card, you're paying an additional $195 for them. So this is something you would have to pay just for having the card. You get nothing for it. Okay? So again, when you get these offers in the mail, be very cognizant and careful and look at this disclosure statement of all the things that you're signing up for and agreeing to. Okay, I always like to share that with students so that they're not making mistakes financially when they get older. All right, so that is the lesson on 4.1, Part 2. If you have any questions, please don't hesitate to reach out, stop in a Google Meet, or ask in class. Have a great day.